Hello students, this is Mr. Damiani and we are going to be looking at lesson 12.8 in your math workbook, and this lesson is located on page 693. So please make sure we're all set and ready to go, and again I'm going to give you another reminder to of course stay fit while you watch this video lesson, and remember this is for educational purposes, not entertainment, although sometimes Mrs. Dubé and I do bring a little bit of entertainment. However, main focus is education, so make sure you are on point, ready to go. The topic for today's lesson is problem solving, working within data displays. So this is the last lesson within chapter 12, so we're going to really kind of bring everything together that we've done throughout the chapter to analyze some problems, word problems. So the essential question: how can you use the strategy of draw a diagram to solve problems involving data? So by diagrams we mean frequency tables, dot plots, histograms, and such. So please follow along while I read. The 32 students in the history club are researching their family histories so they can draw family trees. The data set at the right shows the number of aunts and uncles the students have. What is the most common number of aunts and uncles among the students in the club? All right, so what we're going to try to do is we're going to try to get this data in the table into something that's a little bit easier to identify the most common number, which we know the most common number as the mode. All right, so let's get this organized down below. All right, so what do I need to find following our 3 steps for our problem solving process? I need to find the most common number of aunts and uncles among students in the club. So let's write that in there, most common. All right. The most common number in the data set is also referred to as the mode, something we've already discussed. What information do I need to use? I need to use the number of aunts and uncles each student has from the table. All right, how will I use the information? I can draw a diagram that shows the frequency of each value in the data set. A good way to show the frequency of each value in a data set is by creating a dot plot. All right, so if you're asked to find the mode, usually the dot plot is going to be the best visual thing for you to use. All right, so we're going to start by making a dot plot. Are there the same number of dots on the dot plot as there are in the data values? So what we're going to do is we're going to go up here real quick. We're just going to total our set. And I notice I have a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. I have a 4 by 8, which means I have 32 values because 4 times 8 is 32. And what I'd like you to do now is you're going to take these values from the table here, and you are going to place them on the dot plot down below on that number line right there. All right, so I'm going to pause the video here, let you get that taken care of, and then make sure your dot plot matches my dot plot. All right, so check out those values here. I have 3 on the 0, 3 on the 1. I've got 5 on the 2, 6 on the 3, 7 on the 4, 4 on the 5, 2 on the 6, 1 on the 7, and the 8. All right, so make sure that matched up here. Use the plot to determine the mode. The mode is the data value with the most dots. The data value with the most dots is the 4. So the most common number of aunts and uncles is 4. All right, so we use the dot plot to organize the data and answer a question. What I'd like you to do now is go ahead and turn the page. We're going to hit one more problem together here. So you're going to be looking at page 694 now. And let's take a look at what we are going to be working with. Try another problem. The table shows the attendance for the Pittsburgh Pirates' last 25 home games of the 2009 baseball season. What percent of the games were attended by at least 25,000 people? All right, so we need to figure out a percentage here of games that were attended by at least 25,000 people. All right, which means we want greater than or equal to 25,000 people. And you'll notice if you go to our chart here, it says these values are in the thousands. So it's 12,000, 13,000, 23,000, so on and so forth. But we're going to have to find a way to get this organized and find a percent from that. So let's scroll down and answer our questions here. And what do I need to find? All right. So what I need to find, if you think about it, I got to find a percent of at least 25,000 people. All right. So I'm going to find the percent. Find the percent of attendance greater than or equal to 25,000. I definitely abbreviated that so we didn't have to fill in, a bunch of language here. So what information do I need to use? I'm going to use the data in the table. Of course, data given. How will I use the information? Well, we are going to create a relative frequency table. All right. So a relative frequency table, which means from the data up above, we are going to have to create some intervals. And what I want to do is I'm just going to locate here the smallest and the largest value in the set of data here so we can try to structure some nice, well-organized intervals. So my smallest value as I scan through looks like an 11, and my largest value looks like a 36. So I'm going to have to go basically from an 11 to a 36. And I notice, we're covering 25 numbers or so between that. So we're going to set up intervals for every 5, which means our first interval that we're going to do is going to be 10 to 14. And then we will build our intervals down from there. So let's go ahead and scroll down. And we're going to organize our table. We're going to make a frequency table, and you can create a 3-column frequency table. All right, so let's do this. And the first one's going to be your intervals. Your second would be your frequency. And then this would be your relative frequency. And there we go. Okay. So the first interval that we're going to create is going to be a 10 to 14. And then if we're going every 5, that'd be 15, 20, 25, 30, and 35. All right, because we're counting up by 5s. So that means this is going to be 15 to 19, 20 to 24, 29 to 34, and to 39. All right, so I just wrote in all of our data that we needed for our intervals, making my nice frequency table, and you'll notice it doesn't have to be beautiful, just has to be organized. All right, so what I'd like you to do now is I'm going to have you pause the video, and I want you to go ahead and tally up those values and see if your frequencies match mine. Thank you. All right, so make sure you had 4 for the 10 to 14, 11 for the 15 to 19, 20, 24 had 5, then you had 3, 1, and 1. And if you added up those frequencies, you should get a total of 25 because there's 25 observations from my table up above. All right, so now what we have to do is we have to calculate a relative frequency. Relative frequency is the percent of that frequency compared to all of the observations made. So we're going to calculate a percent. And we are going to focus, if you go back to our question here, we had to have greater than or equal to 25%. So 25 to 29, 30 to 34, and 35 to 39 are the percents that we're going to look for, and we're going to go ahead and add up those percents. Okay, so first of all, I'm going to model the first one here, and then I'm going to have you pause and calculate the next one. So we're going to have 3 out of 25, because I had 3 as a frequency, 25 as a whole, so 3 out of 25. I want to get to 100, so times 4 gives me a 12%. So the relative frequency here is 12%. Now we're going to do the exact same thing here for the 30 to 34, and you'll notice I only have to do one more proportion because they both have a value of 1. So I'm going to have 1 out of 25. Okay, and I'm going to put equals over 100. Again, equivalent fraction rule, times 4, because that gets me to 100, times 4 gets me 4%. So this is going to be 4%, and then that means 35 to 39, which is also a frequency of 1, will also be 4%. Now we want the total percent, which means we're going to add these 3 up here. So I got 12 plus 4 plus 4. That means I'm going to have a total of 20% that were greater than or equal to 25,000. All right, so let's finalize these answers down below here. So the final answer here is 20% of the last 25 home games were attended by at least 25,000 people. All right, and I only did the relative frequency for the values that I checked off here because I wanted 25,000 or higher. I could have applied the same process to find, I could have still done a proportion to find these. We just didn't need them for this problem. I could have also set up a histogram to calculate the percent, but anytime you want to find a percent, that relative frequency table is going to really be the fastest way instead of going frequency table to histogram and then percent. So that's going to be it for our video today. You'll work on applying the concepts from chapter 12 in the video lesson tomorrow in school. What I'd like everybody to do now, though, is you're going to take care of your SQ. And summarizing, you're just going to talk about what type of data displays you can use to organize data from a table. So we've got dot plots, we've got frequency tables, we've got histograms, we've got relative frequency tables, and just make sure you focus on, what type of organization piece or display is going to help you. Like a dot plot, for example, is going to help you. Your dot plot's going to help with finding, a mode. And then your frequency table is going to help. Trying to define frequency or how many of one item. So just keep that in mind as you're working out that summary as well, and then go ahead and write a nice question. So thanks for taking the time to watch the video. I hope you all have a great evening and look forward to working with you in class tomorrow. So goodbye.